Hello, and today I'll be teaching you on the properties of plane areas. Basically, these will be, I would say, more often used in structural analysis. Kind of small thing, but it can make a big impact. Actually, it is the fundamental of any of the structural analysis, right? So first we'll move with what is the centroid, right? So let's call it the centroid, right? Centroid of an area. So the centroid is, right, the point where the whole area of the figure assumed to be concentrated, right? If I talk in Sinhala, මුළු area එකම concentrate වෙලා තියෙන point එකකට කියන්නේ point එක අපි basically කියනවා centroid එක කියලා, right? area එක අපි දැන් හිතුවොත් mass එකක් කියලා. එතකොට ඒ කොටසම mass එක තියෙන්නේ ඒ point එකේ. I would draw it in your figure. Let's consider this. Let's consider this plane, okay, this plate, and I need to know where is the centroid of this, right? So I will make small pieces. I will make small pieces, right? Okay, so each of these pieces will have some weight, right? Each of these pieces will have some plate. මම මේක කෑලි වලට බෙදලා තියෙන්නේ මේ එක පොඩි කෑල්ලකට උනත් මොකක් හරි බරක් තියෙනවා. Okay, so let's say this is W1, okay, this is W2, let's say this is W3, okay. Let's say somewhere සාධාරණ කොටසකට අපි කියමු මෙයා WI කියලා. Okay, WI, right? So I need to know if I'm at here, right? If I'm at here, so this is an axis, right? So let's say this is y-axis. Let's say this is x-axis. So we always refer the centroid with respect to an coordinate system, right? අපි හැමතිස්සෙම centroid එකක් දෙන්නේ අපේ coordinate එකකට coordinate system එකට සාපේක්ෂව. Let's say if I need to find how much distance from this y distance to its centroid. So let's say the total W will act somewhere around here, right? Here you have the total W, right? And that distance is, let's say, y bar. This distance from x to that point is x bar. Okay, we need to find x bar and y bar, right? So what we are going to do is we can take Bendy moments about y-axis, right? So it probably going to bend this way, right? Right? Not to this side, this way, okay? I think this is illusion, right? So this is going to bend this plane in this fashion, right? So that you can find y bar like this. So if you take Bendy moments, right? So you have W1 to to W1, you will have, let's say, X1, sorry, Y1, right? Y1, W2, for that you have Y2. Let's say you have n number of elements, right? This will be n, okay? So for Wn, you will have yn distance. Sometimes this x2, x1 and x2 might be the same, okay? Doesn't matter, we take an expression, we need an expression, okay? So let's say this should be equal, this summation of the moments from the discretized elements is equal to the moments generated from the total element, right? So Wt, for that you have y bar, right? So y bar will be equal, so you can take this summation as mathematical form. Don't worry, this is how we write it, right? Sigma means you have to add it. You have to add it. Y into Wi, right, over Wt, right? So this W, right, can be written as, since this is an area, even so, let's say the thickness is same, so W will be A times thickness times rho, right? You know, rho and G is constant, right, for a particular element, right? So this is thickness, right? This is thickness. Let's say the thickness is same of this play element. So thick area times thickness give you the volume. Volume into density gives you, this is density. Density into G gives you, this is W is mg, okay? M is rho times V, right? V is area times thickness. Okay, I think you got it. These things are constant. So you can even take W is proportional to A, right? Even if you take area, that's fine. You can write it. So let's say if for a small element, you can write dA, right? අපිට මේ පොඩි එලිමන්ට් එකක් අරන් එයාගේ ඒරියා එක dA කියලා ලියන්න පුළුවන්. So then you can write this in mathematical form, y dA. So we simplify this wi into first ai, then that same ai for a small element. So for this is for a small element, you can write it as dA, right? This is just a small element, right? A small area, right? By dA over this is so this is not sigma Wt, okay? So Wt, okay, Wt can be written the summation of Wi, right? Right. So in more general form, summation of area, right? This is proportional, right? Not the same, but proportional. Still you can use it, right? Because you have to multiply it by this constant. So you can divide in, write it in integral form, right? A dA, right? So this is how you derive the expression. This is just an expression to find x bar and y bar. To find x bar, this is going to be, this is x distance, okay? X dA over dA. So where will you actually use this, right? You use this any kind of any place. Just what is this saying? The summation of, right? If you have some complex shape, the summation of bendy moments about its centroid for each element, right? So that will equal to the bendy moment from the whole area, right? Multiplied by its, actually it's a bendy moment, right? Bendy moment is whole area multiplied by the distance to centroid, right? So විදිහකට කිව්වොත් අපි මේ each and කියන්නේ මේ හැම element එකෙන්ම load එක යන තැන වෙනස්. but අපි total load එක හිතුවොත් එයත් යනවා එක තැනකින්. අපි එතකොට මේ එක එක element එක එයාගේ W ක්‍රියා කරන තැනෙත් එක්ක ගූර්ණය අරන් ඒ ටික එකතු කරාම එයා සමාන වෙන්න ඕනේ total load එකකින් මුළු area එකෙම තියෙන centroid එකට තියෙන දුරෙන් වැඩි කරාම. අපි මේක එක example එකකින් බලමු. දැන් හිතන්න ඕගොල්ලන්ට suppose if you have some I section, and a rectangle, right? Right. So this is your x-axis, this is your y-axis. So this is x-axis, this is y-axis. So even grade 5 student know the centroid is x-axis, this is symmetrical. Hence, you have if this is symmetric, so you know this length would be p times 2, right, to the centroid. This distance, if it is symmetric about this distance will be d times 2. Even this one, let's say this is L, let's say this thickness is same, let's say this is symmetric about this axis, and it is symmetric about this axis still, right? So that if this is L, the distance to centroid is L by 2, nothing changed, right? If this is B, right, so this is going to be B by 2, nothing changed, right? So the total load acts at the exact middle. But what happens if you have some change? Or else you have something like this. Right? Okay. If I assume this would be perfectly symmetric about this axis, right? So that your centroid lies on this particular axis, right? So another important point, if you have centroid axis, axis of symmetry, 2 or 3, right, more than 1, you can take the axis, the centroid as the intersection of axis of symmetries. ඔයාලට තියෙනවා නම් axis of symmetry එකකට වඩා ඒ දෙකක් ඡේදනය වෙන තැනදී ටක් ගාලා එන්නේ ඔයාලට centroid එක මොකක්ද කියලා. මේකෙත් axis of symmetry දෙකක් තියෙනවානේ. එතකොට අපි දන්නවා මේ දෙන්න එකතු වෙන ඒ දෙන්න හමු වුණ ඡේදන වෙන ලක්ෂයේදී තමයි මෙයාගේ centroid එක තියෙන්නේ, right? So what happens for this? You have only one axis of symmetry. About this axis, it's not symmetric. So that you only know it lies on this, but you don't know the distance from here, right? Whether it can be here, whether it can be here, whether it can be here, right? You don't know. මෙතන අපිට එක axis of symmetry එකයි තියෙන්නේ. එතකොට අපි දන්නවා එයා අනිවාර්යෙන් ඉන්නේ මේ රේඛාවේ. right? මෙතනත් එහෙම මෙතන අපි දන්නවා මෙයා ඉන්නේ මේ රේඛාවේ ඉන්නත් ඕනේ අනිවාර්යෙන් සහ මෙයා මේ රේඛාවේ ඉන්නත් ඕනේ, right? එතකොට axis of symmetry එකක අනිවාර්යෙන් total w එක ඉන්නවා. එතකොට දෙන්නේ axis of symmetry දෙන්නෙක් හිටපුවාම අපි දන්නවා ඒ දෙන්නගේ common point එකේ තමයි මෙයා ඉන්නේ කියන එක. දැන් අපි ඔක රවුමකට හිතමු. Let's say for a circle have infinite number of axis of symmetry. This is an axis of symmetry. This is, right, when you know these two intersect exactly at the center, right? So that's where the centroid is, right? Even it has something like this centroid. So every axis of symmetry goes to the centroid, right? So what happens here? මෙතෙන්දී ඔයා දන්නවා එයා ඉන්නේ මේ line එකේ කියලා. හැබැයි මේ axis එක වටා එයා symmetric නෑ. ඒ නිසා අපි දන්නේ හරියටම කොතනද ඉන්නේ කියලා. මෙතන වෙන්න පුළුවන්, මෙතන වෙන්න පුළුවන්, මෙතන වෙන්න පුළුවන්. අපිට ඒක හොයන්න තමයි මේ theorem එක පාවිච්චි කරන්න පුළුවන්. හරිද? ඒකට අපි දන්න දෙයක් තමයි, so you don't know where it exactly lies, right? So because it is not symmetric about this axis, right? So you don't know from where you have this, right? Okay. So if you want, you can take bending moment from about this. Okay. If you need, you can take bending moment about this. Doesn't matter, right? If you take about this side plus or that side negative, whatever, right? If I take about this side is entirely plus, this side is negative. So that's more convenient. You can find easily. Let's say I should erase this. So this is you have to discretize this to simple elements. So this is a rectangle, right? This is a rectangle. Let's call this B. This is also a rectangle, right? Let's say this is L. This is also a rectangle. Let's say this is again B, right? And let's say this is 2T, and this is T, and this is 4T. Okay. So again the theorem, the moment of each portion, right? Each segment, moment of each segment is exactly equal to the moment from the total moment at the centroid, right? About any axis, right? So let's say the total W is, this is, let's say A1. This is, let's say, area 2. Okay. This is, let's say, area 3. So the total area is A1 plus A2 plus A3, right? So you have to take bending moments to find the theorem. So let's say A1, this is a rectangle. We know for a rectangle, so what happens when you separate it, it becomes something similar to this, right? There you know the centroid where is, right? You know, අපි මේකෙන් කරන්නේ complex shape එකක් තිබ්බාම අපිට හොයාගන්න බැරි, අපි යාගේ දන්න shape ටිකක් වෙන් කරගන්නවා. centroid එක තියෙන තැන දන්නේවා. අපිට ලේසිම දේ තමයි rectangles. අපි දන්නවා යාගේ centroid එක කොහෙද තියෙන්නේ කියලා. Let's say for this rectangle, right? So A1, let's say A1 into A1 is 40 into B, right? The area into this distance, right? Where, because we are taking moments about this axis, right? This distance is B by 2, right? So A2 is this area. So for that, you have already L by 2, right? This is L, this is L by 2 because it's also a rectangle. But we are taking moments about this, right? So for that L by 2, you have to add a B. B plus L by 2. right? And for A3, you have already B plus L plus, this is the distance to centroid from this, right? It's B by 2, but you are taking moment about this axis, B plus L plus B by 2. So that's going to be B plus L plus B by 2. So this is going to be equal the total area A into so sorry for the interruption. So we were at here, right? So moment of, I think my signal was lost, so I'll explain again. So you convert it to a shape where you know the centroid is, right? So this I can separate into three rectangles, right? For a rectangle, you know where the centroid is, right? So that I'm taking the bendy moments about this axis. Sorry, not bendy moments, the moments, okay? Okay, the moment of area, right? So area is 40 times B, right? That's the area A1 into centroid distance B by 2, right? This area is A2, let's say that's actually L into T, right? So that's okay. If you want, you can substitute. So for that, you have distance of B plus L by 2, right? And for A3, you have B plus L plus B by 2 for that centroid, right? If I draw it for this area, you are taking moment about this axis, this will something like here, right? So to that, for that centroid, you have B times L times this distance is B by 2, right? So you have to take that whole length, right? And that should equal to total area times y bar, right? Y bar is the distance to centroid. That's what we need to find. We know this one. We can find this, we can find this, we can find this. We know these things. You can straight away find y bar. Suppose you have this. It is not even symmetric about any of the axes. No, right? So best thing is you take x and y axis like this and convert it to squares that you know, right? Right. And then similar to this, you can find the distance to centroid. Let's say this is y bar, this is x bar. Okay, so okay, right, so actually this is yeah, that's okay. This axis should be changed, right? Because when you take in moments about y-axis, you have distance of x, right? So this is actually about y-axis, right? If you take bendy moments about y-axis, the distance change is x, right? When you take about y-axis, the change in distance is y, right? Okay. So it is, so if you take about x-axis, right, you have y bar. If you take about y-axis, you have x bar, right? So anything won't change. This equation is fundamentally okay. Only thing is you have to switch the axis, right? That's it. So the second thing is you have to find something like second moment of area. What is the second moment of area? It's the resistance of a section to bending, right? The second moment of area is, you have first moment of area as well. That's not you quite often used. First moment of area and second moment of area, right? So first and second moment of area you have. For this first moment of area, I'll tell you the yes, that's all. So I will, so you can find the first moment of area from this equation. It's a q, first moment of area, right? Qx, first moment of area about x-axis, is equal to, you have to integrate over the area y times dA, right? We'll do an example, right? We do an example. First moment of area about y-axis is so this is x times dA, right? Okay, so it's actually like this, right? So this is actually the area of its uh, moment of area, right? Just moment of area. If you have something like this, let's say this is b times t, right? So this is your axis, x and y axis. It's something away from the x and y axis. So if you take the first moment about this x axis, you need the distance y to its centroid, right? Let's say this is L, So the first moment of area is q, you take qx, okay, about x, but you have the distance of y, right? That's given by this, okay? So area times b times t into dA and to its centroid distance, right? So that's L, right? If you take about this, your qy is going to be, right? Let's say this is to the centroid, okay, to the centroid. Let's say this is, I'm running out of letters, k. So that's going to be bt times the area into k, right? First moment of area. It's nothing. So even if you want, you can take it from the integral form as well, right? So so the second moment of area, that's something special, ix, that is given by integral y squared dA, and iy is given x squared dA, right? And you have something the product of moment of area, right? We call this Iyy and Ixx, called xydA. We rarely use this one, okay, third one, but we majorly use these two, right? So if you say so the second moment of area, right? Second moment of area, what is actually meaning? The resistance of a cross section, right, or a section to bending, right? That's given by the moment of second moment of inertia, right? So second moment of area, we call it moment of inertia as well. So second moment of inertia, so people use lots of wording, but the correct term is second moment of area, right? So it's some kind of inertia, that's true, right? So if you take a rectangle section, right? So we know this is the centroid, right? We define the centroid axis as this, okay? අපි යාගේ centroid එකෙන්ම තමයි x axis එක define කරන්නේ. Or else if you want, you can use this x axis as the x, okay, x dash. Okay, so let's say this is y, and let's say this is y dash. Okay, so x and y axis are going at the centroid, right? Centroid, but x dash and y dash are not, right? Let me draw y dash here. This is y dash. Okay, so okay, so you need to find moment of inertia about x-axis. So this is always given about the centroid axis, right? This equation gives you about the centroidal axis. That means you can use that equation only if it is going through the centroid of this. So if you can find ixx since it is going through the centroid. You can find Iyy since it is going through the centroid, right? You can't find Iyy dash directly or you can't find ix dash directly. Why? The x dash and y dash are not going through the centroid. So this is defined through the centroid, right? Through the centroid for any shape, right? For any shape, right? So let's say this, okay? So we'll take this one. Let's say this x, okay? So we'll take a small element, right? The thickness is dy, okay? Breadth is b. So this, so let's say for this element, you have the to the centroid distance y. Okay? So this is like a line, right? This dy is very small, so that this this y is many times larger than this dy, right? So you don't need to consider y plus dy by 2, right? Dy by 2 is very, very small, right? This is like a line. I'm exaggerating the view, right? ටික ලොකු කරලා පෙන්නලා තියෙන්නේ මේ y dy කියලා අපි තෝරගන්නේ නිකන් කෙස් ගහක වගේ හීනි line එකක්, right? It's like a strand of hair, right? So that you can write ix dash. So always think whether my x axis is going through the centroid. It's right. So you can use this equation. Ix is, you know, y squared dA, right? So y is y, d is what? B dy, right? Y squared b times dy, right? So you can take b out. It's going from, let's say this is d, right? So then this is about the x-axis, this is minus d by 2, this is plus d by 2, right? So you have to go from minus d by 2 to plus d by 2. Okay, so if you integrate this, so b is a constant, you can take it out. B y square y cube over 3. That's going to be this, you have to apply this limit. If you apply this limit, that's going to be b d squared over 8. You can take 3 out, minus d squared over 8. So this is going to be plus this is going to be d squared over 4, so that's going to be bd cube over 12. Ix, right? Ix is going to be bd over 12. So likewise, if it is going through the centroid of y, right, you can write iy, right? Iy as, so just check, this cube b is 4, right? The length where the axis you are taking going through, right? මේ ගණය එන්නේ හැමතිස්සෙම මේ length එකත් එක්ක කැපෙන axis එකට. මේ length එකත් එක්ක දැන් මේ axis එකත් එක්ක කැපෙන length එක වෙන්නේ depth එක, right? Because depth, when you increase the depth, right? When you increase the depth, it have more resistance to bend, right? So that is given by this equation. When you increase depth, the resistance to bending is drastically increased compared to B. Again, or B වැඩි කරනවට වඩා D වැඩි කරොත් our resistance එක ගොඩක් වැඩි වෙනවා bending වලට. So similarly, if you take Y, so this is B, the same equation can be written by, so now the intersecting axis and the length is P. So you have the you have to interchange. So this is going to be dB cube over 2L. Again, you have to check whether it is centroid, right? This y-axis is going to the centroid. If and only if you can use this equation. So what happens if I need to find this x dash, right? So it's simple. What you need to do is, so we know, let's say this is x. Let's say this is the x-axis where you need the I. So we know if this is going to the centroid, let's say this is G. So Ix can be written, right? Let's say this is D and this is B. Okay, I can be written. So the axis, the length cut by the axis is this. This is only for a rectangle, okay? Only for rectangle. So BD cube over 2L, other for other areas, it is changing, right? So you have like D cube, BD cube over 2L. So you need Ix dash, right? What is Ix dash? That means you have to, so you have to bring it to the x dash axis, right? To find that. Actually, you can find this from a simple equation. This is called parallel axis theorem. Ix dash is equal to Ix plus area times y bar squared. This area is the total area. The y bar is the distance to the centroid, right? Distance to the centroid, right? Distance to this axis, right? Because this axis is going to the centroid. Distance to the centroid, that is y bar, right? Squared. This is very simple. So we use all these together, right? So, I mean, when you have some complex shape, you need to what? You need to do what? You need to make that shape from the shapes you already know, right? So that means, let's say if you have an I section, let's say if I have I section, and you have to find the centroid. So if this is symmetric about this axis, you know the centroid will lie on this area, right? This axis. And if it is symmetric about this axis, centroid is exactly at here, right? So nothing you need to worry, right? So let's say this is not symmetric, okay? Let's say this is not symmetric about this axis, okay? But still you can find. So what you need to do is now you need to find for this area, right? This whole area, x there, x, right? You have to find Ix. But you have not rectangular, but one thing, you can convert it to rectangulars. You can see this is a rectangle. This is a rectangle. This is a rectangle, right? This length is not needed to be equal as this, okay? So what happens is if this, let's say this is D and D, okay, this is L, this is B, this is B, this is M, This is, let's say, B. Okay. So since this rectangle, right? So now you can take three areas, right? Three rectangles. So Ix can be written as, so let's say for this, for about x-axis, for this area you have I1, right? About the x-axis for this area you have I2. About this axis you have I3, right? So if you find these three, because you can find these three, those are rectangulars, right? Those are rectangles. You can easily find those. I will use different color. This is for I3. Okay. This is for I2. Okay. So to find I1, let me check this. You just only need to find to I1 whether that lies, whether that the axis you are taking is going through its centroid. No, right? If not, you have to use parallel axis theorem. This is the x. This is, you have to draw an imaginary axis through its centroid, right? About this one, about this axis, right? So, and at the area times y bar squared, right? So this you know. This is always for a rectangular if it is going through. So now it's width times p cube over 2l, right? bd squared over 2l. Now d is actually b, right? Here. So it's going to the centroid now, and a is actually mb, right? Y bar squared is, what is y bar? Y bar is this distance. Let's call this y bar 1. Y bar 1 is going to be d plus b by 2. Right? So that's done. So you will see for I2, you don't need to do anything because the axis where we need to find the second moment of inertia about is going through the centroid, right? So if it is going through the centroid, y bar is 0, right? So you can use this one because it's going through the centroid, right? So that you can find, that is bd squared over 12. Now actually d is 2d, okay? bd cube over 12, right? For I3, similarly, similar to this is, this x-axis is not going through centroid, so you have to draw this imaginary centroid axis and find. So let's say this is for y bar 3. I3 is going to be Ig plus a y bar 3 square. So Ig is nothing but L into p cube over 2l, bd cube over 2l, right? The same equation, only the parameters are changing. A is pl. The distance to centroid is, let's say, y bar 3, so that's going to be d plus d by 2 again, right? Right. So only thing is, let's say this is I naught, this is IG. So if you have some area, right? So this is, let's say, OX. So if you have some area like this, right? It's not going through the centroid of, it's not going through this, let's consider only this area. So you need, or you only need to add these three together, right? To find IX, you will find IX, right? So let's say like this, it's like this, right? So you have X and you have some area which is far away from the axis, you need to find I, right? Because you separate these items, and what happens is, so because now it's not going through the centroid, right? But you know the I given through the centroid, right? So that's, you have it, right? If you don't have it, you have to find it, right? That's something else, right? If it is a rectangle, you know. If it is a triangle, you know. If it is a circle, you know. Those values you have to keep in mind, right? Or else you have to derive from the first principles, right? If it's going through, and then this y bar is distance between the centroid axis and the axis you need to find I, right? Y bar area is the total area, nothing different. If it is somewhere far away from the axis you need, so you have some additional term, right? If it is at here, exactly G is here and it's going through the centroid, so what happened to this y bar? Y bar becomes 0 and this part will vanish. That's why you can directly take the second moment of inertia about centroid as the second moment of inertia about OX axis, because this axis is actually now the centroid axis, right? So we'll do an example. Let's say this is 50, is 50, is 50, this is 100. Okay, since this is symmetric, I won't find the centroid, because I know its distance to centroid is this exactly, right? That's going to be 50 plus 100 by 2, that's going to be 100, right? This is the centroid. So if you don't know the centroid, you have to mark the centroid first, right? If it is not 100, then it is not symmetric about this axis, right? So that means you have a small area, right? You have a small area, so that your centroid will move to somewhere here, right? Because you have less area from this. That means centroid area will lie to the will go move toward downwards, right? In that case, you have to find the centroid axis in so that I can take these three areas. And these three. So let's call this I1. I1 is now, I1 centroid is not So we need ix, right? The centroid of this part is not going through the ix, so you have to use parallel axis theorem. But to find that, so about centroid of plus a into y bar squared. So you know this is not going to change. Bd cube over 2l. So b is 100. Is 50. Or 12 plus a is 100 into 50 into y bar is 100. This is 50 plus this distance. It's 50 by 2, 25, right? 25 plus 50. So that's going to be 75. I1. This will be the same as I3 because the same I about centroid, it's centroid, not the X, right? 100 into 50 cube over 12 plus 100 into 50. Distance to centroid is 50 plus 25. So that's 75. So for this area, centroid is exactly going through that centroid, because even if you separate these two, still this is symmetric about these two axes, and centroid of this small rectangle lies on the exact x-axis, right? So I2 is, you don't need to use parallel axis theorem because it's the axis you need to find second moment of area is going through the centroid of that part, right? BD cube over 12, right? So if you need to find ix, so ix will be I1 plus I2 plus I3. That's an easier way to find this as well. How? You can see this is actually coming from a rectangle, right? This is the rectangle, right? This is the rectangle. So if it is a rectangle, let's say this is D, let's say this is B, but it has to be symmetric. It has to be symmetric. It can't be like this, okay? Then you are in trouble. Then you have to use that previous method. But if it is this is symmetric, right? So you can see your I of this one lies on the same centroid axis. So you can write BD squared over BD cube over 2A, right? And you are reducing two squares, and those, the centroid of those squares are also centroid. Let's say centroid is here, this square, right, lies on the same axis, so that you can write, still you don't need to use parallel axis. For even for this, you don't need to use parallel axis theorem, right? Centroid of this lies on, because this is symmetric, okay, assume this is symmetric, lies on this axis, right? Let's say this is C, let's say this is A, let's say this is A, and this is C. So what happens is, from that square, you reduce those two smaller squares. So you remove I value of BD cube over 2L of small square, right? And the other square, that is also AC cube over 12. So from this way you can find easily, right? So you have to be concerned about what you are doing, right? So if you have some area like this, let's say this is X, let's say this is Y, so this is, let's say, the centroid. So IXX is now what? PD cube over 2L. So what happens if I move this square along this x-axis? Nothing happens, right? Nothing happens because it is independent of the distance along x-axis, right? This is not dependent on the distance along the x-axis. So that means even if you move along the axis, this I value is not going to change, right? But if you move it on the y-axis, now your centroid lies here, right? This is your centroid axis. Now this your centroid axis and g-axis are the same for at this level, but here it's not, right? So you have to move it to centroid. So this will be your y bar, right? So this is the area. You take the centroid and you multiply the area by the y area into y bar squared, and you find the I if it is here. But still, if you move this along the x-axis, it does not depend on this x value, right? So it will give you the same I value, right? Even if you move along, but if you move diagonally, so that y value will change, right? But not depend on x, right? If it is moving through the x-axis and you are taking ix, it's not going to change. Same thing apply when you take I about y. So if you are moving about this y-axis, iy is not going to be changed. But if you are going to move along the x-axis, so your iy change. So you have to use parallel axis theorem. In that case, that is going to be iy is I centroid. Now the centroid y-axis, okay, plus a into, now this distance we call it x bar, okay, the distance between the axes, right? Again, the parallel axis theorem, nothing different, right? So I hope you understand that, right? And please keep it mind for a triangle as well. If you for a triangle, shit. Let's say this is G. Say this is H, and this is P. Okay. So you can find yes, you can find. Now this is the axis going through its base, not the centroid, but people have found that as ix, as they know the value ph cube over 12. It's similar to the rectangle, but it's not going through the centroid. But you can find the centroid. How? You know, for the centroid you have, this is h by 3, that it's 2 to 1 ratio, right? H by 3, this is 2h by 3, right? So this ix is actually, now you invert, so you have to go reverse in the parallel axis theorem. How? Now you know this one and this one, you have to find the centroid one, right? This is bh squared over 12. Bh squared over 12. You have to find this. This is area is half times BH, and y bar is the axis, the difference between these two axes, right? This is the centroid axis, this is the axis we are taking. As there is h by 3 to so that is going to be h squared over 9. So you have to ph cube you take out, 1 over 12 minus 1 over 80 is Ig. So that's going to be, this is 36. For 36 you have 3, for 36 you have 2, so this is going to be bh cube over 36 Ig. Yes, for yes, I have to keep those things in remember, because these things may come in handy, right? Even when you are doing structural analysis, right? And let's say you don't move the axis, but you rotate the axis, right? You don't move the axis, but you rotate the axis. What happens there? Right? So people have solution for that. So first thing you did was, let's say these were x and y. So you move, so you have now moved this x-axis to here and y-axis to here. So you have to find this. Let's say if your axis is like this now, and you rotate the axis about this, these two axes. Now this is your x coordinate system, like this, right? Let's say this is x dash and y dash is theta. This is x and y, right? People have found, if you know x ixx and iyy, you can find this. Now please remember, if you need to find ixs, you can see the centroid axis is this. Okay, you have to, for sure you have to use parallel axis theorem to find even ix, right? Let's say you know ix and ixx and iyy, and iyy you know, right? So people have found, so your ix dash is going to be ixx plus iyy divided by 2 plus ixx minus iyy divided by 2 into cos 2 theta, right? Minus ixy. Let's say you know ixy as well. These three you have to know. So I told you what is ixy. Okay, you can find it the same principles using, that's easy, this one. For that also you have to use parallel axis theorem. If you use parallel axis theorem, that's going to be quite bit change. That's ix dash y dash for parallel axis theorem will be ixy this is not the x dash y dash here. Okay, so I will use here ixy. If you use parallel axis theorem, ixy, the polar moment of inertia at centroid. This is the axis you need. Let's say this is x double dash and y double dash, because this is not the dash axis that we're talking here. Okay, this is something like this, ox y, right? Plus x bar y bar dA, x bar y bar a, right? A. I will write this at the final slide. Don't worry, I will write it. So people have find this. This is ixy into sine 2 theta. And iyy dash minus iyy divided by 2 into cos theta, cos 2 theta, plus ixy sine 2 theta, right? But what happens if you add these two together? Ixx dash plus iyy is equal to, if you add these two will cancel. So this is going to be ixx plus iyy, right? So what is this? So we call this actually polar moment of inertia, I naught, right? So we call it IZZ. Right? So that polar moment of inertia is independent of the rotation angle, right? You can see, even if you take some, the same angle should be here, 90. Okay, even if you take x2 y2, ix2 plus iy2 should be IZZ, right? That is not dependent on the rotation angle. We call this polar moment of inertia. And even if you take perpendicular to axes, if you add ixx and iyy, that is equal to polar moment of inertia, right? So these are the things you have to keep in mind. And I told you I'm going to give you that parallel axis. So if you, let's say you have to so this is okay when you are rotating, and when you are translating, let's say it's like this. So this is ix dash and y dash. This is this is going through the centroid, okay? X and y. Okay. Okay, so ix dash is parallel axis theorem. Ix plus a y bar. This is y bar squared. Iy dash is iy plus a times x bar squared. This is x bar. and Ixy dash is Ixy plus x bar y bar a. So please keep in mind, right? If you have any one of the centroids, so these parts will be 0, right? Because x bar y, if you have centroid axis, so these parts are 0, right? Exactly centroid. Let's say it's a centroid is now here, right? So your y bar becomes 0, so your y bar going to 0. Let's say your area is here, so y bar is not 0, but x bar is 0. This will go to 0. So that means about y dash, it will directly give by, it will be directly given by this, but for x, you have to use parallel axis theorem because y bar is not 0. Let's say if your y is actually here, so both 0 and here also, here anyway 0, one of them 0, that will be 0. Okay. So I hope you understand that, right? So you have to practice this until it's get perfect, right?